Hello everyone, greetings from India. This is Nirbhay Chauhan from Eklavya Self-Learning Tutorials. Well, today in this video, I'll be giving a demonstration about my thesis project. Well, in my thesis, I have developed a code compliance rule engine entirely based on IFC, that is the Industry Foundation classes, and this project is based on BIM, that is Building Information Modeling. So we have worked for the structure element, that is RC slab, reinforced concrete slab, and this project can be further taken to other structure elements also. Well, I'll be showing you a brief demonstration at how it works, what report does it generates, what input does it take. Well, this was a totally practical project. I should not say this was an academic project. No doubt this was for the purpose of thesis, but my guide suggested and made us to learn and guided in such a way that the project could be practical as much as possible. And along with me, the GSOC student Amritpal Singh also has given a lot of his effort, and a lot of contribution is also given by him for this project for the coding part. So I'll be discussing about that. So let's start. Let me just make myself a little smaller. So yes, let's start by just viewing the model in the solid body. Let me just show you a sample model. Suppose, let's take this one. So we made a IFC file from any of the BIM software, like this is generated from Autodesk Revit. So we just made a structure building with all the necessary structural components, and as much as if we try the architecture components also, like the wall openings, terrain, walls, etc. So let me just show you a sample slab here. So you can see there are necessary rebar details in this as per the realistic RC designs. So what we have done basically, our rule engine will read all the IFC information of this model and generate the report as per based on Indian standards IS 456, that's for the RC slab. So all the, you can say, the design criterias, wherever the design fails or wherever the particular check is passed, the report will be generated and will tell us that which check is passed, and if any check is failed, it will also tell us by what value the check is failed. So let me just tell you a little some of the faults. Like we have this IFC here, like site, building, and all the particular levels. Suppose we open level 4, and for our purpose of the project, we have provided the reinforcement details in slab only. So let me just show you one interesting thing here. When you will open the slabs folder, you see these are the slabs, but we can't see the rebar details because as per the IFC files are exported by the BIM software, these reinforcing details are exported as a separate entity. We are not able to group the rebars, or not we, I should say, the BIM softwares are not able to make these groups. Like we have, if we see a particular construction hierarchy, if I just show you here, you can see we have a particular site. Then side there can be several buildings, like we have a building here, then that building there can be different levels, like this building has overall 6 levels. Then those levels can have different structure elements, MEP elements, architecture elements, whatever. So here are beam, columns, openings, reinforcing bar, slab, walls. So now the catch, one thing is here, these reinforcing bars should be grouped as per their parent member. Like suppose we have reinforcing in slabs only. So we know the reinforcing bar should be in all these slabs, but unfortunately the reinforcing details are grouped as individual. We're not able to see them as hierarchical as they are other elements. But if we see, IFC has defined all the grouping like by IFC rel aggregates. There are several other things. IFC rel contained in spatial structures. I can just show you here. I already opened. This is the building smart documentation for IFC 2 by 3. So if I just show you the entities, the structure entities of IFC rel aggregate. Let me just show you. IFC rel aggregate is used to group. So here it is. So if you see definition also, it clearly tells the aggregation relationship between the composition and decomposition relationship between IFC decomposes. So basically these are things. So I have just done manually also by manipulating the IFC file, the text file which is generated by just understanding and making the IFC aggregates of the rebars. So when I just saw in Solibri, those were grouped. So this is quite, you can say, surprising thing that why the BIM software, the leading BIM software, in order to do this. I tried Tekla also, I tried Allplan, I tried Revit, I also tried the open source software, the FreeCAD. So right now, none of the BIM software is grouping this thing. I think this is very essential because IFC has defined everything. IFC is defining like how the grouping should be done, what are the properties to be exported, but we are failing. So we have necessary information, whatever was required. So based on that geometrical information and some of the information was we made patches like we made the IFC file, then the IFC file was open in FreeCAD, that is open source BIM software, and there we have the function name inside. So through that we made the grouping of rebars and save that file in FreeCAD. So our rule engine basically what that does is that open this IFC file along with the FreeCAD file where we can do our operations, the backend operations, and then we can apply our checks, all the digital formulas. Let me just show you the FreeCAD file also, like what the mechanism is. So this is a file name demo building 6. Let me just show you here. So you see demo building 6 is here, along with we have demo building 6.fcstd. This is native format of FreeCAD. So we have two files here working with our rule engine. Whenever we import the file, the IFC file, the FreeCAD file is also run at backend where the grouping of rebars is done, because this was something very necessary. By eyes we can see that which rebar is belong to which structure element, but through program we have to just show some relation. So for that we made this patch, and after that the work was pretty much okay. And still now there are some of the, you see, difficulties that we face that I'll be showing you in my next presentation of my thesis where I have described everything. But this is a demo of the project or the rule engine that we have made. So this is a practical project. We are moving forward for this project and we are planning our best to make some more advancements, and we are also working with the bimserver.org, that is an open source BIM server where the client can exchange the files and revisions can be done. So let's move towards the rule engine. So we have kept the rule engine the FreeCAD directory. So this is the rule engine.py. For some circumstances and I may not be able to show you the code, I'll not be sharing that. So let me just show you the function of this rule engine. So in the PowerShell, let's just run this rule engine. So let's just refresh this PowerShell. It may take a while. So now we have this rule engine. So here we have. Now after just pressing enter, so now it's asking about enter a file name without extension. So basically we know we are interested in the file name demo building 6. So let's start with that. Let me just type here demo building 6, enter. So now this rule engine, or we can say this PowerShell operation of the Python, will further ask us to enter the floor names. Earlier this used to come here only. So now basically it is importing the project files. So the both the IFC and our FreeCAD file. So now both the files are being imported in this. It takes some initial time for the first time. So we're running it now. So now when the files will be imported, the IFC file of this demo building 6, it will ask us about some further inputs. Let me just show you along with this. So right now we are dealing with this file. It has, if you just make transparent, you can see there is a lot of rebars here. But we are dealing with only RC slabs right now. We have covered RC slabs only. So see, now it is showing us all the levels contained in that particular building. So now we have to choose any of our interested level. Let us say we choose level 5. So now it shows all the slabs which are contained in that particular level. So we can choose any of the slab we are interested in. Let us say we choose this slab by name. We just copied the name of the slab. Now just simply press enter. So now it is asking us enter Y to proceed checks of other slabs also, or enter N to close the program. So right now we are interested in on this slab only. If you want to just proceed to other slabs also, you can just say N. So let us say N and press enter. And now our CSV file is generated. Let us just proceed to that. It will be contained in this folder only. So you can see this date is 4 September, it's today. So this is a CSV file, you can open it with Notepad. So it is by the name of that particular slab you see. Let me just open the Notepad file. So you can see here, report of code checks on RC slab as per IS 456. So this is basically developed by us, GCE, that is the group of our testing and consultancy cell, GD for great developers and GCE for great civil engineers. And that's by my colleague Guru Nanak Dev Engineering College Ludhiana, and the whole project is guided by Dr. H.S. Rai. So we dealt with the IS 456, that is the Indian Standard Codes. So you can see the checks which are made here, like the type of the slab is two-way. Then it told that about the minimum longitudinal reinforcement check is passed, transverse reinforcement check is passed, and then you can see here the vertical deflection limit of slab is not satisfactory. There are some ratios here, so you can change that. The spacing is passed. Then you can see the failing here, like the longitudinal over reinforcement check is failed by this much amount. Transverse is also failed, longitudinal balance reinforcement check, and it is also telling us about the moment carrying capacity of slab and the moment check that is failed, and it's also telling us about the maximum load that can be carried by slab, that is 132.48 Newton per mm square. So you see the report is quite satisfactory. We can just extend this report also, we can make some more checks, we can add some more details, so the project can be carried forward. So all this you can see the stuff here. The main effort that took was to just implement and read this whole documentation of the IFC 2x3. Not whole, I should say. There are like 653 entities at all. So we did a study all the entities that we needed for this project: IFC site, IFC buildings, IFC slab, IFC floors, levels, all those things that we needed. IFC reinforcing bars, the particular you can say inheritance graphs. So that was all the stuff that we basically needed for that. So this was a all brief, I should say, demonstration of the project, of my thesis project. If you have any question, you can ask in the comment section below, or you can contact me. And we are eagerly looking forward to extend this project to a whole new level, to cover all other RC elements also, and make it somewhat more realistic as much as possible. It is quite satisfactory now, And there were some things like we had to manipulate with the BIM software, like what details we want, how details we need. So there were some loopholes, I should say. Like every BIM software has its own standards. That's also not good thing, I should say. Like Revit has some its own, Tekla has some own. So in Revit, one thing I found good was we can just extend our I should say depth of the detail, like material properties, rebar properties. So there were a lot of modifications that we can do, which were there in Revit. So in Allplan we tried the Tekla, FreeCAD is going right now. So all the software was good, but they were not, I should say, in the case of interoperability, they're not following the proper standards. So now we have done the project for the IFC, and IFC also, if you see, they has been doing a lot of shout is going on for the IFC promotion, open BIM promotion. But when it comes to implementation, I don't think there's anything much going on or any good thing is going on. Interoperability is a major issue, versions, revisions in all the eco industry. But the problem can be solved only by IFC and the OpenBIM. And we need to focus and we need to make more and more developments and more, I should say, niche developments in this technology. So that's all for today, I should say. I'll be coming with one presentation, detailed presentation of this project that was covered in my thesis. Well, that's all, my dear friends. See you in next video and tutorial. Thank you so much. This was Nirbhay Chauhan from Eklavya Self-Learning Tutorials. Goodbye. Have a good day. Thank you so much.